Hi, I'm Paul from Test Data Services, and in this video I'm going to talk about load and performance testing on a global scale. So when we're talking about a global test, we're taking into account devices that are distributed all over the world. In a normal test in a lab inside an organization's network, everything is co-located. When we do cloud-based testing, we often do it in a single region. But in real life, we have situations where we've got laptops and mobile devices, tablets, desktop computers spread out everywhere. And when they visit a web page or some resource, they fetch a lot of things from locally provided CDN endpoints and edge server endpoints. Now, the best way to test that is to run activity from those locations. So, for example, if we have a web page that makes a request to an application under test, it then makes an initial request, but it does a whole stack of interactions with other servers in its local region, or maybe not in its local region, before finishing off and maybe doing a few extra requests, and then eventually rendering a final page. Now, that response time is very important, and it's dependent on a lot of things. And if we measure those devices from only one location, we won't get a real sense of things, of the performance. Now, there's a number of CDNs around, and some of them, like AWS have them. Akamai used to be a very big player. They maybe still are. There's lots of different CDN providers, and they have edge locations all over the place. They have thousands of them. Now, if we run our tests from one location, we're going to, and we're running browser-based tests, those browsers may make necessary requests for fonts or for CSS files or for anything really that's critical for the loading of the page. They may make them from the same server or a group of servers that are co-located, and you don't get an idea of what the performance is like when you're testing everywhere. It's improved if we run a test from not just one region, but let's say we run it from 10 regions or 12 or 15 regions. Like in this page here, you can see we've got some edge servers or edge locations notated, and we've got users. Now, those users will interact with those edge locations before fetching data, in this case from AWS S3. But if we run a test from there, then we would actually see the impact of those flows, those network flows on our performance. So to run a proper global test, it's good to at least have a bunch of regions, and I often run from AWS regions. That gives you a very good, very repeatable experience of performance. But better than that is to actually run from individual people's homes if it's a consumer test that you're running. So that's what I'm going to talk about next. So what I've been using to do these tests, well, I've just started using really, is NeoCortex. So this is the website, and as you can see, they've got a big focus obviously on these last mile endpoint locations, which are people's ARM-based mobile devices, which you can look at the website and go to, and you can run all sorts of workload on there. You can just even fire up a Linux shell on a machine that's nice and safe. It's someone's device. It's plugged in probably at night time, is my understanding. But if I was to go to my dashboard and have a look right now, refresh, I can see that I'm actually running 130 instances right now in a test. I fired it up from a batch script, a Python shell, and a Python run, and I didn't use the UI. I think that's why it says there's no tests running. But I'm running these 130 users at the moment, and if we were to look at scalable compute, you can see they've got the devices in 50 countries, and these are the locations. So I'm running a test now, and when I finish the test, I'll actually be able to show in a map where my locations are from. And the script that I'm running, it's a Gatling load test, and it actually embeds in it, well, I fetch from within the script the location. I do that from one of my API endpoints from Test Data Services, but I understand that NeoCortex have a service so you can find out roughly where you are as well. So that's what I'm doing to get all of these distributed endpoints. So the advantage of running a test from all these different locations is that if you've got slow first request times for pages on edge locations, you've got a better chance of actually catching that with this type of test. If you have poorly configured CDN components, or if you've got a CDN service you're paying for and it's not set up in all regions, you'll quickly notice that. So I think that's pretty cool. What I'll show you next is some of the processes and the script that I'm using, and then I'll show you the results. So I've just fired off a script, and if I scroll back here, you can see I ran Python 3 run batch gatling.py, and that fired off this job it's launched all those instances, and it's doing its thing at the moment. What it's basically running is this Gatling test. So I'll zoom in on this one so you can see it best. And it's a very simple test. What it's doing is it's packaged neocortex that's necessary to have, and you have to specify you basically have to make sure that you connect up what's in the Python script to the Gatling script so it knows what things to run. But without explaining that, because I don't want to get into it, basically it does two requests in this test. It's doing a get workload request. I'll put a link up in the top right on a video that explains how that works. Basically, this get workload request allows multiple load generators to all run that are independent and very loosely coupled with the controlling solution, so that we can stop and start workload whenever we like, or we can run a very complex and dynamic workload profile. I'll put another link up that describes an example of that as well. So this particular request, actually I'll show it to you in Postman just so you can see. If I fire this off now, then this particular subscription, I'll put this one in the link below so you can run this. Like, you can actually just run this as a get request whenever you like, but it returns a country code. It does that because this API request is served by AWS Edge servers, and it knows where the request is. So it actually tells you, using the IP address, but it still knows where it is, where it's coming from. So if I was to just paste up here that request, like I said, I'll put this in the link below. You can see the country code. If you run this yourself, you'll get a different country code if you're not in Australia, which I reckon is pretty cool. So what the script is doing is, let me go back to, oh look, we're running a test at the moment. That's the thing scrolling. You can recognize that Gatling. If you're very fast at reading, you can recognize that Gatling output. And let's just go back to here, the script. This is the script. So we're doing that workload request, and we get a run workload, and we get a country code back. If the run workload is a 1, we do the next thing, and if it's a 0, we don't, and we find out what the country is. Then, so we've got here this test, do if equals run workload 1. Then we're going to actually generate a request to do an OpenID Connect authorize. I'll put another link up the top, which basically does a random login type transaction with OpenID Connect to give us back a OpenID Connect token, basically a JWT, which is signed and has a certain amount of validity to it. So we basically get an access token and an ID token back. Now, I'm not doing anything with it. I might do another script later on with actually a mock e-commerce site so that you can actually see how to leverage that JWT. And the real reason, or the novel thing in this script, is the country code. Oh, there's two novel things. I'm running the script on a whole stack of ARM devices that are people's phones in all sorts of countries all over the world, which I think is really fantastic, using the last mile of network, real life network. So while it's not necessarily repeatable if you run the same test, you're not going to get millisecond equivalent response times. You're getting a really good sense of what a real user would experience. Now, in this case, it's a simple API request. You're not going to have all of those requests going back to CDN endpoints and so on. But if you're running something that actually made those local requests, like a page, and you can do anything in Gatling pretty much, then you would get the benefit of that. So we've got this request being fired off, but we've got also the specification here. In this case, each of these scripts, when they run, will run for 10 minutes, 600 seconds, and it will do 6,000 iterations spread over those 10 minutes. So basically, we're doing 10 transactions a second. Now, because we're running hundreds of, or more than 100 devices, we will actually see a large number of requests per second coming in. So the country code is available to the script, which means that we have a regional jurisdiction context. If we're running an e-commerce system with a checkout, and Canada has different tax requirements in the form or delivery requirements to US or Germany or France or Russia or wherever, then you can actually have a case statement in your script that handles that, and your script does not need to be allocated to each region. It just runs in any region, which I think is pretty good. So I'm going to let this test run. Then I'm going to show you some analysis from it. And basically, this might be the first time you've actually seen a last mile load test on a global scale. And I reckon it's pretty fantastic. All right. See you in a minute. Well, the test's now finished. And we can see this is the last bit of the log here from the test, where it finished up. I can see that it cost me about $2.20 to run those instances, which is not too bad. If I run a quick analysis, I can see that these are the numbers of transactions for get token for random user with the country code embedded, which is what I pull out of that get workload call to find out where I'm running it from. So we can see we've got US, Russia, GB for Great Britain, I imagine, D, I'm not sure where that is, CA, maybe Canada, I don't know, but we can see there's a bit of variation. So we get 693 millisecond average for this call. The get workload call was also included in these totals. The way I just did this quick script, I was just really pulling out the get token from random user. It's just so when you run a test, a Gatling test, you get a directory with all of the results and all of the output for each of the instances. So this script is just going through all of those, and it's just pulling this together. You can then do some analysis on those numbers, those raw numbers, and do whatever you want with them. Oh, you do get a image. This one. There we go. This is the image you get back automatically from the Python run that calls the Gatling test, and you can see here the locations. You get other graphs as well with transaction response times, but I'd prefer to just use my own analysis. But it's still nice to be able to see that they are the locations they came from. Basically, I've done a run with a Gatling test, and you can use any Gatling script that works. Will run. I've tried a bunch of them, and the best thing is you get last mile performance. You can do any amount of analysis post-test that you like because you get all of the data for every transaction, and your script can be contextually aware of where it's running from, which means that in one country where you have to do an extra answer or an extra question or different workflow or different servers or different whatever, your script can handle that, which is great, and then you can report on the different performance like what I've just summarized here by region or by country. So I think that's pretty good. So hope you found this video on performance testing on a global scale useful, especially from a last mile perspective. Have a great day.